Curve C has the equation y equals x to the power 4 minus 8x squared plus 3. Part A says to find dy by dx. So we're going to differentiate this function. The x to the power 4 will multiply by the 4 and take 1 away from the 4. The minus 8x squared will multiply by the 2 and then we'll take 1 away from the 2. And then the 3 is a constant, so that's going to differentiate just to be 0. So that's the answer to my part A. dy by dx is equal to 4x cubed minus 16x. Part B says to find the coordinates of each of the stationary points. Now I know at a stationary point the gradient is equal to 0. So all I need to do here is to take my gradient function that I found in part A and make it equal to 0. And we're then going to solve that. To solve this, I can factorise 4x outside. And that will leave me with an x squared minus 4 on the inside. So now I can see that either the 4x is going to equal 0, either this is going to equal 0, or the x squared minus 4 equals 0. So 4x will equal 0 if x is equal to 0, and x squared minus 4 will equal 0 if x squared is 4, or if x is 2, or x is minus 2. So these are the 3 x coordinates of my stationary points. I now need to know the y coordinates for each of these. Then I'll have the coordinates of each of the stationary points. So if I substitute the x coordinates into the original function, so first of all for x is 0, I get 0 squared minus 8 times 0 squared plus 3, which is 3. So when x equals 0, y is 3. If I now substitute 2 in, so I get 2 to the power 4 minus 8 times 2 squared plus 3 is going to be minus 13. And then finally, if we do the same thing with the minus 2, so we do minus 2 to the power 4, minus 8 lots of minus 2 squared plus 3, we actually get minus 13 again. So these are the 3 coordinates of my stationary points. Part C says to determine the nature of each stationary point. So this is saying, is it a minimum or is it a maximum? Well, I know that a minimum is when the second derivative is greater than 0. And I know that a maximum is when the second derivative is less than 0. So let's check at each of these points. Let's find out the value of the second derivative at each of these points. So I first have to differentiate for the second time to get the second derivative. When I differentiate 4x cubed, I'm going to get 12x squared. And when I differentiate the minus 16x, I'm going to get minus 16. So when x is 2, when x is 0, let's start with the 0 here. When x is 0, this is going to equal minus 16. Because we get 12 times 0 squared minus 16, which is minus 16. So therefore, the second derivative is negative. Therefore, it is a maximum. Next, when x is 2, Let's substitute 2 in here. And we get 12 times 2 squared. So 12 times 4 is 48. 48 minus 16 is 32, which is positive. The second derivative is positive when x is 2. Therefore, that means that this would be a minimum. And then finally, what about when x is minus 2? Let's substitute that into the second derivative. When I substitute minus 2 into the second derivative, I get 12 times minus 2 squared minus 16, which is 32, which is again positive, so that is also a minimum. So we've got 3 stationary points. We've got a maximum at the coordinate 0, 3, and then we've got 2 minimums, one at the point 2, minus 13, and one at the point minus 2, minus 13. Part D. We are told that the point A lies on the curve and has x coordinate 1. We need to find an equation for the normal to the curve at A, and we need to give our answer in that form. So the normal is a straight line, so I'm thinking y equals mx plus c. And crucially, I know that the normal is perpendicular to the curve at that point. So it's going to have the negative reciprocal gradient. The normal is perpendicular to the curve. Therefore, it is going to have the negative reciprocal gradient. So let's figure out what that gradient is. Well, let's take our gradient function, 4x cubed minus 16x. And at point A, the x-coordinate is 1. So let's substitute that in. We've got 4 times 1 cubed minus 16, which is minus 12. So the gradient of the curve at A is minus 12. Therefore, the gradient of the normal is perpendicular to that. So it will be the negative reciprocal. So it will be 1 over 12. We can now say y equals mx plus c. We now need to substitute a coordinate into this. I know that the normal goes through point A, where the x-coordinate is 1. But I don't know what the y-coordinate is yet. But that's fine, because I can work out the y-coordinate by substituting the x-coordinate into my original function. So 1 to the power 4 minus 8 times 1 squared plus 3 is minus 4. So my y-coordinate is minus 4 when the x-coordinate is 1. So substituting that into my equation here, I've got minus 4 equals 1/12 times 1 plus c. So minus 4 equals 1/12 plus c. Add the 1/12. So we're going to subtract the 1/12 from both sides. So the minus 4 minus 1/12 is c, which is the same thing as minus 49 over 12. So our equation would be y equals 1/12 x minus 49 over 12. And now I just need to write that in the form that the question's asked for. So I'm going to simplify this by multiplying through by 12. So I'll get 12y is equal to x minus 49. Take 12y away from both sides. And this is how I'm going to leave my answer.